Today I would like to talk about composition of functions. Okay, so we're going to be given two functions, f and g. The composite function f composed of g of x is equal to the function of f evaluated with g of x everywhere the function f had an x. So we're going to take one function and we're going to put it inside of the other one. So this is the notation, f composed of g. You might hear an instructor call it fog for short. We have another way. We could take g composed of f of x. That means we're going to take the function of f and replace it in x in the function of g. Okay, so in this one we take g of x and we put it inside f of x, and in this one we take f of x and we put it inside g of x. There's also two others that we could do. We could have f composed of f, or FOF. So we're going to take our function of f and put it inside of itself. And we could do the same thing with g, or GOG. So g composed of g, we're going to take g and we're going to plug it inside of itself and evaluate it. Okay, so f composed of g, g composed of f composed of with f, and g composed with g. Okay, and again, you might hear an instructor call this fog, goff, fof, and gog. Okay, for short. And when we're doing this, we really want to be careful with our domains. Okay, so the domain of f composed of g is the set of all numbers x in the domain of g such that g of x is in the domain of f. So basically, we want to look at our domains for each of our two functions, and if we have a domain restriction in g, that is also going to be a restriction in f composed with g. If we have a restriction of f, we have to figure out what would make g equal that domain restriction, and that is also a restriction in f composed of g. Okay, and I know that sounds wonky, but let's look at a couple of examples, and hopefully that becomes a little more clear. Okay, so just looking at domains. Let's say we're given the functions f of x equals 3x plus 2 and g of x equals 2x squared plus 3. Okay, so looking at g of x, that's all real numbers. Excuse me. And the domain of f of x it's also all real numbers. The first one is linear, the second one is quadratic. We know the domains of these are all real numbers. So I don't have any domain restrictions in g of x. I don't have any domain restrictions in f of x. And that means that my domain of f composed with g is also all real numbers. Okay, we'll look at another example in a few minutes where it's not going to be all real numbers. But for now, when we started these problems, we do want to be taking our domains into consideration. So I found my domain of all three. Let's go ahead and start making our composite functions, okay? And again, we have 4 that we can find. F composed with G, G composed with F, F composed with F, and G composed with G. So we're going to take these two, f of x and g of x, and we're going to find all of these different composite functions. Okay, so just so we can remember, f of x is equal to 3x plus 2, and g of x is equal to 2x squared plus 3. And we want to find the composite function of f composed with g. And remember, that means we're going to take our function f and we're going to replace all of our x's with g of x. Okay. So here, f composed of g of x equals, I have my 3, then I have an x, and I need to replace my x's with my g function. So 2x squared plus 3, and I still have my plus 2 on the outside. And now I need to simplify. So I'm going to go ahead and distribute this 3 into my parentheses. So I end up with 6x squared plus 9 plus 2. Don't forget this 2 on the outside of the parentheses. Don't accidentally take this 3 and multiply it over here by the 2. Okay, it's not in the parentheses. It's not being distributed to that. And finally, we can simplify. We end up with 6x squared plus 11. And again, the domain here, as you can see, we ended up with something that was quadratic. So it is going to be all real numbers still. So that's our first one. We can also find Goff, g composed of f of x. And remember, that is our function g, and we're going to take f of x and we're going to replace it everywhere we see an x. Okay, so that is equal to 2. Then I have an x, and so I need to place my 3x plus 2 in the parentheses. That was squared, so this needs to be squared, and I've got plus 3. Okay. Now, we do want to simplify this as much as possible, so we need to FOIL out our parentheses, then we can distribute our 2, and then finally, after all that's done, we'll add 3 in. Okay? So my side work here, I need to find 3x plus 2 times 3x plus 2. Okay, that gives me 9x squared plus 6x plus 6x plus 4. And I can simplify that one more time. 9x squared plus 12x plus 4. And really, now what we're working with is 2 times 9x squared plus 12x plus 4 plus 3. Notice I don't have my square on the outside because I actually multiplied everything out right here, so don't make that mistake. Okay? Now I can distribute my 2 across into the parentheses. Okay? That gives me 18x squared plus 24x plus 8 plus 3. And then finally, the only other thing I can simplify is 8 plus 3. That gives me 18x squared plus 24x plus 11. And again, we ended up with something quadratic, so our domain, again, would be all real numbers. We could also find f composed of f of x. And remember, there we're going to take our function f of x, and we're going to take f of x itself and put it back inside of it. So we're composing it with itself. Okay, and just to recall, f of x was equal to 3x plus 2. So f composed of f of x equals 3. I have an x here, and that means I need to replace it with this entire function itself. 3x plus 2 plus 2. Then I can distribute the 3 across my parentheses. That gives me 9x plus 6 plus 2. And the last thing I can do here is add my 6 and my 2. So I've got 9x plus 8. Again, you can see we ended up with something linear here, so the domain would be all real numbers still. Okay, we have one more we can find, g composed of g of x. Remember, we're going to take our function g and evaluate it inside of itself. Okay, and just to recall, g of x was equal to 2x squared plus 3. Okay, so finding the composite function, g composed with g of x. Okay, I have a 2. Then I have an x. And remember, I want to replace x with this function itself. So 2x squared plus 3. Okay, I have that x being squared, so this needs to be squared. Then I have plus 3 on the outside. Okay, again, let's do a little bit of side work. Let's find 2x squared plus 3 times 2x squared plus 3. Okay, I'm going to FOIL this out right here. 2x squared times 2x squared gives me 4x squared. 2x squared times 3, 4x to the 4th, I'm sorry. 2x squared times 2x squared is 4x to the 4th power. Then 2x squared times 3 gives me 6x squared. 3 times 2x squared gives me 6x squared. And then 3 times 3 gives me 9. And I can simplify this one more time. I've got 4x to the 4th plus 12x plus 9. Okay, so what I'm looking at here is 2 times 4x to the 4th plus 12x plus 9 plus 3. And again, we've already dealt with this square here, so it's not here. Don't make that mistake and keep adding it on, okay? The next thing I can do is distribute my 2 across my parentheses. So that gives me 8x to the 4th plus 24x squared plus 18 plus 3. And finally, the last thing I can do here is 18 plus 3. That gives me 8x to the 4th plus 24x squared plus 21. Okay. So finding these composite functions, it's just a practice in your algebra skills, really. You want to put one inside of the other and then simplify it as much as possible. Okay? Be very careful that you know which function you're putting in where. And one of the easiest things to remember is that we work backwards. I took g and I put it inside of g. Here I took f and put it inside f. Here I took f and I put it inside g. And here I took g and put it inside f. Okay, so these are also giving you a direction. Let's look at another example. So example 2, let's say f of x is equal to 1 over x plus 3 and g of x is equal to negative 2 over x. So these are not linear or quadratic, these are rational equations, so we do need to consider our domain here. Okay, my domain of g of x is x such that x cannot equal 0. Okay, so we can't have 0 in the denominator here, so this is our domain restriction for g of x. And f of x, our domain, is x such that x cannot equal negative 3. Okay, so I can't have 0 in this denominator, so I am looking for what would make this 0, and negative 3 plus 3 would be 0, so here's my domain restriction. Now, to find fog, I need to consider both of these domains. And I'm going to take my function of g of x and I'm going to put it inside f of x. That means I cannot have my function g of x equal to negative 3, because that would make all of this equal 0, and then we'd be left with something undefined. Okay? So what I need to do is, I know what my domain restriction is, I need to see what is going to make g of x equal negative 3. Okay, so I need to look at negative 2 over x equals negative 3. And I need to figure out what value of x is going to make this happen. Okay, so if I were to multiply both sides by negative x, on the left-hand side, my x's will cancel out and my negative signs will cancel out. So here I'm left with positive 2 equals, and then negative 3 times negative x gives me positive 3x. Okay? And then to solve for x, I just have to divide both sides by 3. So here x equals 2/3. That means my domain restrictions for f composed of g is going to have to include 2/3. Okay? So my domain of g of x, we said was x such that x cannot equal 0. And I know that 2/3 here would make this equal 0, my f function over here. So my domain of f composed of g of x is x such that x cannot equal 0 and x cannot equal 2/3. And you'll see why once we actually find this composite function, okay? But sometimes it's easier to just find it this way. It's a good idea to look at your domain restrictions first. So let's find f composed with g. If I was going to find g composed of f, I would have done the reverse. Okay, I would have looked at what was going to make this equal 0. And then that value would have been added on into my domain restriction. But we're not. We're looking for f composed of g. So f composed of g of x. Remember, I have 1 over x plus 3 but I want to take x away and I want to plug in whatever g of x is. Okay, so that is going to equal 1 over negative 2 over x plus 3. Okay, so let's do a little bit of algebra and simplify this. So 1 over negative 2 over x plus 3. Remember, before I can add these together, I need a common denominator. Remember, 3 is 3 over 1. So to give it a common denominator, I'm going to multiply x over x to 3. That gives me 1 over negative 2 over x plus 3x also over x. Now that I have a common denominator, I can rewrite this as one fraction. So let's do that. I still have 1 over negative 2 plus 3x all over x. And remember, when you have a fraction inside of a fraction, the way we simplify this is we take the reciprocal of the denominator and we multiply it back to the top. And since our top is just 1, we're just really flipping this upside down. So this is equal to x over negative 2 plus 3x. Okay? And as you can see here, this is going to be that other domain restriction. I can't have this be 0. So just some side work just for my own benefit. Negative 2 plus 3x cannot equal 0. That means 3x cannot equal positive 2 because I added 2 to both sides to clear it. And dividing both sides by 3, x cannot equal 2/3. Okay, so that domain restriction pops out also. You don't want to just solve for the domain restrictions after you've composed of it, because looking at the function that we've created, I could stick 0 in here. If I stick in a 0 for x and a 0 right here, I'd have 0 over negative 2, which is still equal to 0. But that's not our function. Our function is created from 2 of them. So I had to make sure I did not include my domain restriction of g. Okay? So this would be my composite function f composed of g. So really make sure you know how to find your domains for any type of function. Remember your domains of rational functions. Remember your domains of radical equations, okay? Anything involving a square root or something like that. There's another type of problem you may see in this section. And they're going to ask that we show that f composed of g of x equals g composed of f of x, and it's all going to equal just x. Okay, so it's not always going to happen. This is a special relationship. We'll talk more about it in the next video, in the next section of your textbook. But let's say that we have f of x is equal to x plus 5, and g of x equals x minus 5. So finding f composed of g of x, so that means I take g and I plug it inside of f. So f starts with an x, so I need to replace that with g. And then I have plus 5, so here I need plus 5. Okay. I have these parentheses to show myself what I'm inputting in for x, but looking at it, I don't really need them. So I can just let them go, and I'm looking at x minus 5 plus 5. The only thing I can simplify here are my 5's. Negative 5 plus 5 is 0, so I'm just left with x. Okay. We were asked to show that fog equals Goff. Okay, so I still need to find g of composed of x. G composed of f of x, excuse me. So starting off, I'm going to take my function f and plug it inside g. Okay, so looking at g, I start off with x. That means I need to replace that with x plus 5. Then I have minus 5. And again, I don't actually need these parentheses. I do it for my own benefit to make sure I don't lose anything if I had a coefficient out front or a square, something, okay? But here, excuse me, here I don't actually need them. So I have x plus 5 minus 5. Again, I'm only able to simplify my constant, so 5 minus 5 is 0, and that is certainly equal to just x. Let's do another example like this. Let's say we have f of x equals x cubed, and g of x equals the cubed root of x. Okay, so looking at f composed of g, or fog, I'm going to take g and I'm going to plug it inside f. So here I've got x, and remember I'm replacing my x's with the other function, so I've got the cubed root of x, and on the outside I have a cube, so I have a cube right here. Okay, so by now we should realize that this radical and the exponent are going to cancel each other out, and we're just looking at x. Okay, the index on my radical is the same as my exponent. If they were both 4's, they were both 5's, they were both 2, then they cancel each other out. And all I'm left is what is inside, okay, the x. And the same thing, finding g composed of f of x. So I need to take f and I need to plug it inside g. So for g, I have the cubed root of x. And everywhere I see x is what I'm replacing with my first function, x cubed. And again, the cubed root of x cubed, you should recognize that by now, that the radical and the exponent cancel each other out, and we're left with just x. Okay, so don't think that every time this should happen. Okay, it's only in special circumstances. So looking at these problems, the instructions should tell you to show that f composed with g is equal to g composed of x, and that reduces down to x. Okay. There's one more type of problem that you should probably see in this section. So, example 5. Find functions f and g so that f composed of g of x is equal to another function h of x. Okay? And normally here, not normally, for these style problems, h of x should be given. Okay? So let's say h of x is equal to x plus 1 to the 4th power. Now, we want f composed of g of x to equal h of x. Okay? And remember, f composed of g of x is some function f with g of x inside of it. So looking at h of x again, this is inside a set of parentheses raised to the 4th power. We could certainly say that this is going to be g of x. Okay, so if I took x plus 1 and I plugged it into a function everywhere I saw an x, that tells me that f of x here is x to the 4th, and g of x is what is inside of it. Okay. And then you can find the composite function to check yourself. Okay, so if I'm going to take g and plug it inside of f, looking at f, I've got an x, and for that I need to plug in g, x plus 1, and then I have the 4th power, so I still need the 4th power, and that is certainly equal to h of x. So in these problems, in these types of problems, it takes a little bit of critical thinking, but just remember you're looking for something that you plug inside of another function. Okay? And that is composition of functions.